Look, I don't know why everybody's making sigma notation look complicated. It is not, believe me. And today I'm actually going to help you understand sigma notation in 3 simple steps. The first step, you will learn how to find the number of terms in the series. That is the first step. And the second step, you will learn how to expand sigma notation. And in the last step, obviously, you will determine whether it's an arithmetic or a geometric series. Okay, let's get into the video. So what they do in sigma notation is they give you this term at the bottom. This I don't even know what it's called, but they say n is equal to something or k is equal to something. If they say n here, they also have to say n here. If they say k here, they also have to say k here in the formula. I'll call this the formula because it's the formula, obviously, right? So what they do is they say n is equal to, now this one, this term is the starting term. This one is your first term, right? It's where you start. And then this one is going to be a last term, the 5. All right, step number 1, determine the number of terms in the series, right? For this, we say top minus bottom plus 1, right? So the top that we're talking about is this one, the 5. We will say 5 minus 1 and plus 1. Now this one is just going to be 0, so the number of terms that are present in the series are 5, right? So step number 1 done. 5 terms. Now this is very useful, especially when n in your series is not 1. If you have a 3 here, or maybe a 5 or a 13 or something like that, and you also have 1,000 here, it is going to be complicated for you to find how many terms you have in the series. So the best thing would be saying top minus bottom and then you add 1. There you go. Step number 2. Alright, for step number 2, we are going to expand this thing, this sigma notation thing right here. So how do we do that? We simply take the formula and we plug in n. Now this is where n starts, this is where n ends, right? So let us do that. Now you work out this quickly in your calculator, and this one is going to be 2 times 1, this one is going to be 4, 6, 8, 10 and 12. 1, 2, 3, 4, 5. Now for the last step, we are going to try to identify if this one is a geometric series or if it's an arithmetic series, right? So how do we do that? We know that for arithmetic series, we have the difference, and for geometric series we have what we call the constant ratio. So let me do this side. We are trying to find if maybe it's a geometric geo, and this side we are trying to find out if maybe it's an arithmetic, right? So for arithmetic we say t2 minus t1, right, is equal to t3 minus t2, right? So let us do that real quick. And t2 is going to be 6 minus 4 is equal to 8 minus 6. So this is 2 is equal to 2. That is our difference. The difference is 2 is equal to 2. So it is obvious that our difference is 2, right? But let us just say we made a mistake and we thought this one was a geometric. Let's see if maybe we are going to get a constant ratio. For geometric, we say t2 over t1 is equal to t3 over t2, right? So what is t2? T2 is 6 and t1 is 4, is equal to 8 over 6.